Hi there, my name is Vishnu Dutt, and in this video we will continue our discussion on border node in SD-Access. The focus of this video will be on packet walkthrough when a user tries to leave the SD-Access fabric. This means how the packet flow looks like when a user wants to access an application in data center or wants to talk to remote sites. We will also discuss what happens when a user tries to reach a server on internet. To begin with, consider this diagram. We have SD-Access campus network here, which is running Lisp plus VXLAN. This campus network is connected to the data center through internal border router. So this router here is the internal border router as it is connecting known routes. You can run any protocol of your choice between this border router and data center router. Here we are running BGP or Border Gateway Protocol. In SD-Access, the border configuration is automated, which means the BGP and route redistribution configuration is pushed by the central controller, which is DNAC. So to explain it on very high level, mutual redistribution of routes is configured between Lisp and BGP. We have a control plane node here, this one, which is responsible for replying to map queries from edge or border nodes. Don't worry about these empty boxes, these boxes. We will fill them during our packet walk. This user, on this one, wants to communicate to the server, this one here, present in data center. The IP address of this user is 10.1.1.10/24. If you have gone through my previous videos, you can easily figure that this address is part of overlay network or fabric. All those nodes such as border node, control plane node, and edge nodes have corresponding loopback configured on them. This loopback is part of the underlay network. This user will create an IP packet that is destined towards the server in the data center. Let's fill the content of the IP packet created by this user. This one here. The source IP address of this packet will be 10.1.1.10 and the destination IP address will be 172.16.1.10. Okay, correct? Simple enough. When this packet reaches the edge node here, this node, the edge node will query the control plane node about the location of 172.16.1.10. Okay, so here is the map request. Control plane node consults its database, this one here, and finds the matching entry. The database says to reach 172.16.1.10 server, edge node needs to forward the packet towards remote location 1.1.1.5, or in other words, network address 172.16.1.10 is behind 1.1.1.5, which is the remote location of border router. This is simple, right? Control plane node sent this information to edge node using map reply message. So here we have the map reply message. Okay. Now this edge node knows where exactly to forward this IP packet, which has come from this user, right? As you know, edge node will slap a VXLAN header and encapsulate the VXLAN packet into another IP packet. So this box, this little one, represent the IP packet from the user plus the VXLAN header slapped by the edge node. As I mentioned, the VXLAN packet is encapsulated into another IP packet. Let's write the content of this new IP packet. The source IP of the outer packet will be the loopback address of this edge node, that is 1.1.1.1, and destination IP address will be remote location of the border router, which is 1.1.1.5. This packet will traverse in underlay to reach the border router here. this one. The border router will decapsulate the packet to get the inner IP packet. After decapsulation, the source IP address of this packet will be 10.1.1.10 and destination IP address will be 172.16.1.10. This is because we have decapsulated the packet and remove the outer IP packet. Border router knows how to forward this packet as it has BGP learned route for the network 172.16.1.0/24. Hence, border router will forward the packet towards its next hop, which is the data center edge router. This one here, this router. Okay. This data center edge router will eventually forward the IP packet towards the server. This is quite simple. Correct, guys? One thing to note here is how control plane node has information about the 172.16.1.0/24 network. This explanation is simple. The border node imports or redistribute the data center routes learned via BGP into Lisp domain. Hence, control plane node, which is part of Lisp domain, knows all the data center routes. Once again, very easy to understand, right? Now let's discuss about the reverse traffic flow. Consider this diagram. What happens when this server, this one, wants to communicate to a user in SDX's campus network? As we discussed, this border is redistributing all the fabric routes or Lisp routes into BGP. This data center knows about all fabric routes. Once again, let's fill the content of the IP packet. The IP packet generated by this server will have source IP address of 172.16.1.10 and destination IP address as 10.1.1.10. The edge router will forward this plain IP packet to border router. The packet will reach here at the border router. Border router will send a map query message towards control plane node asking about the location of 10.1.1.10. Control plane node consults its database and found that the remote location of 10.1.1.10 address is 1.1.1.1. Or in other words, IP address 10.1.1.10 is behind the edge node having remote location address of 1.1.1.1. Here, this one, right? It will send this information in map reply packet to border node, correct? For now, let's leave the priority field that I mentioned here, this priority field. We will discuss this in our hands-on SDXS video series. Now border node has all the information to forward the packet. Border node will slap the VXLAN header on the IP packet it received from the server and encapsulates it into another IP packet. The source IP address of this encapsulated packet will be 1.1.1.5 and destination address will be 1.1.1.1. This small box here, this one represents the IP packet plus VXLAN header which got encapsulated in this IP packet. This packet will be forwarded in underlay and reaches to this edge node here, this one, correct? Edge node will decapsulate the packet and forward the plain IP packet towards the user. The source IP address of this packet will be 172.16.1.10 and destination IP address will be 10.1.1.10. Correct, guys? So far, so good. Now let's discuss the packet walk when the same user wants to talk to a server present on the internet. For that, consider this diagram. Here we have this server in the internet cloud and our campus user wants to talk to it. Here we have the border router, this one, correct? The type of this border router is default border as we will be using it as a gateway of last resort. When we define a particular border router as a default border, the automation engine on DNAC configure this default border router as a gateway of last resort on all edge nodes. The meaning of gateway of last resort is that if there is no matching route for an IP packet in the routing table of the edge node, it will forward the packet to its last resort, which is default border. In Lisp terminology, we call this router as proxy edge tunnel router or PETR. Now let's fill these empty packets. This user will generate an IP packet towards the internet. The source IP address of the packet will be 10.1.1.10 and destination IP packet will be 100.100.100.100. Correct? Simple enough. When this IP packet reaches at this edge node, the edge will query the control plane node for the remote location of the internet server having IP address of 100.100.100.100. The control plane node consults its database and doesn't find any match. Control plane node reply with map reply message, which indicates that it couldn't find a remote location associated with address 100.100.100.100 and edge nodes needs to use gateway of last resort or proxy egress tunnel router. In this case, the gateway of last resort or PETR is the default router with remote location 1.1.1.5. Now edge node has all the necessary information to forward this packet to default router. Edge node will slap a VXLAN header on the IP packet it receives from the user and encapsulates it into another IP packet. This is the packet, this one. So this little box is the original IP packet plus VXLAN header. This will be the outer IP packet. The source address of the encapsulated IP packet will be 1.1.1.1 and destination address will be 1.1.1.5, which is the remote location address of the default border router or default border node, this one here. The packet will reach to border router. Border router will decapsulate the packet and eventually forwards the plain IP packet towards the internet. Here is the plain IP packet with source IP address of 10.1.1.10 and destination address of 100.100.100.100. This is important to know why the edge node is slapping a VXLAN header on the IP packet. This is explained in detail in my previous videos on SD access data plane. The other concept which is still remaining is about the fusion router. We will discuss fusion router in our next video. If you like my videos, please do not forget to subscribe my channel as you will get notification for all new videos. Hope you have enjoyed this video. See you in next one.